Dr. Memari again, and we have pre-lab discussion for experiment 4, which is extraction. The type of extraction that we are going to perform in this experiment is called acid-base extraction. Extraction could be for purification of solid, or it could be purification of a liquid, as long as the component of the mixture or the sample and the impurity, they have different pH or they have different acid-base property. If you have mixture of 2 acids, you cannot use extraction to separate them. If you have mixture of 2 base, you cannot separate them. But if you have acid and a base, then you can separate by extraction, and I will tell you how. If you have acid with neutral compound, you can separate them. But if you have 2 neutral compounds, you cannot. So the purpose for this experiment, first of all, to learn about extraction. And second, we are going to perform the experiment and separate a water-insoluble organic acids from water-insoluble organic neutral compounds. So we are going to have a mixture of organic acid and organic neutral compound, and we separate them by extraction. So the acid-base property of this organic compound is going to be used. In extraction, we are going to have 2 layers. We are using a separatory funnel, and in the separatory funnel, we are going to have, this is just something to support, we are going to have 2 layers. One layer is going to be aqueous layer, and the other layer is going to be organic layer. Now, which one is going to be the aqueous or organic layer? That depends on the density. If the organic solvent has higher density, like methylene chloride has higher density, it would be the bottom layer. If the organic layer has lower density, it's going to be the top layer. So it's not the top layer, always the organic layer. Now, at the beginning, when you have organic acid and organic neutral compound, both of them would dissolve in organic solvent, like ether. And then we are going to change the pH or use the sodium hydroxide in order to change the organic acid and change that to salt of the acid. And because it's a sodium salt of the acid, is going to dissolve in aqueous solution, and it will come into the aqueous layer. So if we have proper organic solvent, what is a proper organic solvent? First of all, when we are talking about organic solvent, means that it's going to be used for the organic layer. It cannot be miscible with water. Like alcohol is organic solvent, but since it's miscible with water, cannot be used for extraction. Ether is good, methylene chloride is good. Those are the 2 common ones that are used for the extraction as the organic solvent. And they should not react with the compound, and they should have like low boiling point, so you can remove them easily by evaporating. Because what is our concern is to separate the compound, not to have it mixed with the solvent. So we have to be worried about separation at the end. Some points to remember. Organic compounds with carboxylic acid and phenol functional groups, they are acid. So if they have these 2 functional groups, they are classified as acid, and they react with sodium hydroxide. Amines, they are base. If you have organic compound that has amine functional group is going to be base and is going to react with HCl. Now, any other organic compounds that doesn't have carboxylic acid, phenol, or amine functional group is considered as neutral compound. That includes alcohols, aldehydes, ketones, and others. There are two useful reactions here that we are using actually in the extraction. One, carboxylic acid, the first reaction shows carboxylic acid with sodium hydroxide would change to ionic compound. This is the salt that is water soluble. And because it's water soluble, it will go to the aqueous layer. The second reaction is showing that if you have the salt of the organic acid and you mix it with HCl, it will give you back the organic acid because the acid HCl is going to remove the sodium and it gives back the hydrogen, and it's going to be insoluble in water. Okay, so if you had insoluble in water, reacted with sodium hydroxide, changed to the soluble, and it goes to aqueous layer, and that's how you separate it.
And that's actually have you recover from the aqueous solution.
As I said, the equipment that you're using for extraction is a separatory funnel. And in the separatory funnel, like this, for the setup, you have a ring stand, you have a proper size iron ring, and you place your separatory funnel. The stopcock must be closed when you are pouring liquid in, and it's going to be closed in the horizontal position. The glass stopper must be greased because when you are shaking the separatory funnel, you kind of invert, and when you are venting, basically meaning that you're opening the stopcock here and let any accumulated gas that cause pressure or build up pressure to be released. And often this needs to be done inside the fume hood and not facing you or someone else. What else you need to remember? Organic layer, which contains the organic compounds, could be the upper or lower depending on the density of the solution. You want to grease the stopper, as I said, because when you invert it, you don't want the leak of you don't want the sample to leak. Okay. The venting frequently. You want to remove the pressure that builds up, especially if you have acid in the funnel and you're washing with like bicarbonate or carbonate that's going to produce carbon dioxide gas. It builds up pressure. Or you're using solvent that has low boiling point. If it's low boiling point solvent, it's going to evaporate and it would generate vapor, which is going to cause significant pressure buildup. And you must vent it often. And venting, one more time, you hold it like upside down by holding it tight to the stopcock and to the glass stopper, and turn it open to the vertical position, and let the pressure to be released. And you have to do that when the separatory funnel is sitting on the iron ring. The stopper must be removed when you are draining the lower layer. If it's not removed, it would create vacuum and is not going to come out, and sometimes it would breathe from the stopcock area and it disturbs the two layers. How does extraction work? The extraction work because your compound is more soluble in one solvent compared to the other. Like if you have a mixture of the acid and neutral compound, after you mix with sodium hydroxide, the acid is going to be soluble in aqueous solution, but the organic compound would be soluble in the organic solvent. The ratio of concentration in the organic solvent versus the water or aqueous solution is known as KD. And that KD, or partition coefficient, it can determine how efficient is your extraction. So if KD is 10, what does it mean? It means that your sample is 10 times more soluble in one layer compared to the other layer. So every time you do extraction, you get like 10 times more of that compound removed, like you get 90% of the compound removed. And then you often do like multiple extraction. Multiple extraction and multiple washings are more common because the first time you're not getting 100% of the desired compound. So you do multiple extraction. When the procedure is asking you to wash the organic layer with water, that's just to remove any water-soluble impurities. So if there are water-soluble impurities, you wash it by water. When it tells you to wash it with sodium hydroxide, that's like to remove traces of acid. Sometimes it's going to ask you to wash with sodium chloride or saturated sodium chloride. That is to increase the KD value. What does it mean? It means that organic compound, it doesn't dissolve in salt water. Or another term is called like salting out the organic compound. It leaves the salt water much faster than the water. So you are lowering the solubility of organic neutral compound in the aqueous solution. In extraction, after the organic layer, which contains the neutral compound, is removed or is separated, it needs to be dried. Dry, meaning that if there is any moisture left or mixed, needs to be removed. And for that reason, you are using drying agent. Drying agent could be like calcium chloride, sodium sulfate, magnesium sulfate, potassium carbonate. But for this experiment, we are using calcium chloride mesh or pellets. The sample must be dry completely before you measure the mass or the melting point of the solid compound. And we talked about, especially the melting point, if it's not dry, it would be lowered and the mass would be higher than what is expected to be. So you want to make sure to dry your sample. This diagram here, it shows the steps for the extraction. So basically, you're going to start with the mixture of the acid and the neutral compound. You're going to dissolve that in ether, then extract it 2 times with sodium hydroxide. And every time you add sodium hydroxide, you are going to get the aqueous layer, which is the salt, and you are going to collect that. And you do 2 times and you're collecting it. The neutral compound stays in the ether layer. Use the anhydrous agent to remove the moisture. And then you're going to evaporate the ether and end up with the neutral compound in solid form. Because if you start with solid, you end up with solid. For the aqueous solution, which is the salt of the acid, after adding HCl, is going to go back to the organic acid, and organic acid is not going to be soluble in water. Only if it has less than 5 carbon, it would be soluble in water. But if it was solid and it was not soluble in water to begin with, then when it changes, when it reacts with HCl, it changes to water insoluble solid compound. So it would crystallize. You're going to separate by vacuum filtration. You're going to, while it's on the vacuum filtration, you're going to wash it with cold solvent, just like recrystallization. So this part of the experiment is just like recrystallization. So you're repeating recrystallization here. And you are going to wash it and make sure that it's completely dry before you measure the mass and you measure the melting point. You measure the mass to calculate percent recovery, and you measure the melting point to determine the purity of the sample. And this is the last part of the experiment for our extraction. Thank you. I hope that it's helpful for you to do better on the Prelab quiz. Read the experiment, watch this video for Prelab discussions, and before you take the quiz. Thank you.